first part of this is entitled Best Practices of Organizations with Optimized Dose. Again, the same disclosure has no real overlap with the talk that I'm going to share. So I think meaningful variation in dose is real. I'm going to show you one more slide that I think dovetails nicely with Dr. Sadekson just showed about if the dose is 10 millisievert and what that means. The later talks, both today and over the next 2 days, are going to focus on how to manipulate the technical settings to lower doses. But the 2 talks now are really much more focused on why some organizations have lower doses. What about those facilities had led to doses? We saw from the 2 presentations earlier by Matt and Pavlina, I think how much work it is to optimize doses, and just to look at that from a perspective of what kind of facilities are getting it right. And then really the second talk is about sort of this part of the talk is what institutional leaders say are factors that basically enhance or impede dose optimization. I want to show you a slide of data. I apologize for all the numbers, but just to help contextualize where it is that the doses are aberrant from that average abdominal dose that Aaron described. This is a screenshot from a paper describing doses for routine abdominal CT. It's coming out in European Radiology, I think, this week or something like that. These are data that we've assembled between 2015 and 2020, and this slide includes data on 748,846 CT scans, all done for routine abdomen indications. So there are no studies in here that were done for kidney stones. There are no studies that were done for angiograms to look for bleeding in the abdomen. These are just routine abdominal indications, all from data in the UCSF registry. I'm highlighting here, I have one more important thing to say. These 700,000 exams are ordered by the doses that were received. So basically, we organized the protocols. We looked at the average DLP, that adjusted for patient size, and we lined up all those protocols, like I described earlier, lining up the patients, and then broke all those different protocols into 10 groups by decile. The lowest decile had an average DLP of 295. If we I'll explain what that means in a moment, the DLP. Aaron talked a little bit about it, but if you look at the 10% of protocols that had the highest dose, it was 1,892 DLP. So a tremendously different value. So low dose, high dose. If you look at some of the other columns, you can see that most of these parameters increase, not all of them, from the first row to the last, but I want you to look at the patient diameter. This is how big the patient is. And the first decile is the average, the mean is 309 millimeters, and the highest is 312 millimeters. And what this means is that the great variation in doses does not have anything to do with the patient size. The patient size is the same in all these groups. It has to do with what decisions were made by those local institutions to scan these patients. It wasn't because of why the person had the scan. They're all routine abdomen, and it wasn't because of anything about the patient. What Aaron told us is that his calculations of what sort of risks are were based on an estimation that the effective dose, I'm showing you effective dose, was 10 millisievert. And indeed, the fifth decile, that's the average in our group, had precisely the dose that Aaron was using, 10 millisievert as the estimate. But what I want to show you is that 10% of the patients got a dose on one abdominal scan of 30 millisievert. Again, this is not the extreme. This is the 10%. Their average was 30. And on the other extreme, the first decile had an average of 4. And so I think it's important when you think about risk to understand the whole range of risks. And patients who get a really high dose, 3 times that average, have much higher risk than those have much lower. So it's just important to realize that there's a lot of variation there. And it's real. This is size-adjusted dose. often people say, well, you haven't taken into account patient size. Of course, there are high dose patients. They're really large. This is showing that if you adjust for DLP, the numbers don't change. These differences are not due to patient size. They're due to local decisions. The effective dose I've already talked about. So the average dose went from 4 to 30 across our different deciles. Big differences. And why are those doses so different from one variable to the next? I told you in the BMJ paper that we used very detailed data on patients in the scanners, and we assessed what factors contributed to doses. And radiation varied by these factors. I'll show you another figure later that showed smaller patients have much lower dose than larger patients, but the difference due to patient size did not account for variation across institutions or countries. Those variation differences were real, but they didn't explain why one facility has so much higher doses than another. The variation was due to local decisions and protocols for scanning. And for this work that I'm going to share, we really wanted to understand what characteristics of a facility would result in decisions that resulted in lower doses. It's not what the machine comes with. That kind of is all the same. It's rather how they made decisions. And all facilities that participated in our registry were champions, had a champion at least for lowering dose. That's why they participated in our study. They wanted to lower their doses. They cared about doses. They were using dose management software. So we had a champion at every one of our 166 hospitals, but that wasn't enough. That wasn't enough to get doses lower. So in terms of our registry, we created this registry for two purposes. First, to describe variation in dose, but second, to see if we could lower the doses through education. So we had a large grant from the National Cancer Institute and from PCORI to see if we could help organizations lower their doses through audit and education, and to do the surveying that I'm going to describe next. So as part of our registry, we invited participants to participate in a randomized controlled trial. Basically, they joined our registry, and we did different things to try to help them lower doses. We gave them audit information, that comparative information that we have found is really valuable to organizations. But we also tried other things. We call it a multi-component intervention, which was audit with particular suggestions. This is how you can lower your dose, education, and sharing of best practices. And to participate in this trial, sites had to agree to actively participate in an 8-week multi-component intervention. They had to be willing to do that. They could be in our registry without doing that, but to be in the trial, they had to be willing to do that. And so in the end, we had 100 imaging facilities that agreed to participate. They were from 19 different healthcare organizations, and they participated in this prospective trial. And it had different components, as I mentioned, the audit, the detailed 8-week intervention, the sharing of best practices, and mentoring of performing quality improvement, meaning they would perform quality improvement. We would educate them on how to do quality improvement. And quite honestly, I had to bring in people to educate me with the rest of my participants in how you do small tests of change and how you are able to tackle quality improvement at a small scale without being overwhelmed at having to do it for everything. There were 3 tracks in our trial. Everyone, all of the 100 imaging facilities got all the interventions, but they got them in different orders to allow us to have a good study design. And this was published a few years ago in JAMA Internal Medicine. I'll show you sort of 2 slides of the results of that study, and several of the speakers that we have at this meeting, including several from this morning, were members of this group. This graph is showing the dose at each point in the trial based on and compared to the baseline. So you can see there's a value of 100. That means 100%. That means this was a weekly value of average dose of all of the centers that were in that part of the intervention, meaning it was before the audit at baseline. And each week we have a different average, kind of hovering around the average of 1 or 100%. And then we had different parts of the intervention. We had the audit, we had the multi-component intervention, and you could see that the doses each week of the intervention came down. These are the median dose for abdomen and pelvis CT. This is the percent of exams that were above the 75th percentile. And it shows that the average came down and the 75th percentile came down. The high dose exams were reduced up to 60% in the trial. So bigger change in the high dose exams, the outliers. The average doses were reduced 40%. The variation was reduced by 40%. And we did not measure image quality, but we asked the physicians about image quality, and they reported no change in image quality. They were greater than 90% satisfied at each point. This next slide shows change in organ doses. Again, I've told you it doesn't really matter so much what we measure. The results are fairly similar. This shows the change in organ doses after the multi-component intervention. So I'm showing you abdomen doses for abdomen CT, chest doses for chest CT. This says C, lung doses for combined abdomen and chest CT, abdomen doses for combined chest and abdomen, and head doses for head CT, brain doses. These were the proportion over the benchmark, meaning what percent of exams were above the 75th percentile at baseline, and then proportion after the multi-component intervention. So abdomen doses went from 25% to 18%, almost 7% reduction in the doses. You can see all these numbers are in the correct direction of lower doses after the intervention. The odds ratio is the odds of a higher exam, the chance of it. So 0.6, there was a reduction. 0.75 means there was a 75% reduction, and all the p-values were highly significant. So giving feedback to facilities, again, very motivated facilities, resulted in meaningful lower doses and no change in doctor satisfaction with image quality. Again, we didn't measure image quality, but it's the radiologist's job to work with the medical physicist to ensure they get images that are acceptable for diagnosis. And so they did careful monitoring, and there was no change. So that was the result of our intervention, but we also did surveys at baseline to ask about different aspects of the organization, basically to learn how they performed CT, how they did quality improvement. The goal was to better understand why some facilities had lower doses at baseline compared to others. And the surveys were conducted at our 19 organizations in 26 states, plus England, Netherlands, Germany, Japan, and Switzerland, places that participated in our trial. 6 of those organizations had only one facility, one hospital or imaging facility that participated. The remaining organizations had between 5 and 39 facilities. We had one very large organization that participated. These surveys were completed by the organization's principal investigator and a leader at each individual facility and hospital. So we had basically 19 leaders, and they identified the right person to work with us on these surveys at each of the individual facilities. And the participants could be whoever was identified by our PI, be it a radiologist, technologist, medical physicist, or administrator. And so we have all the radiation dose measures at baseline. I've shown you some of those. And we looked for, after adjusting for patient factors, age, gender, size, and in our analysis, each of our quality improvement measurements, the strategies that I'm going to show you soon, we were tested to see which ones were associated with the mean abdominal CT radiation dose and the odds of a high dose exam at baseline. We chose abdomen just because that's the body region that's the most common exam that we do in the US. It slightly outpaces head CT for the most common study type, and it's the one where there's the greatest variation. There's far less variation for head doses, and they tend to be lower. So we focused for this on abdominal doses. And our survey was quite broad, and we brought in experts on both survey design and to really understand what are measurements that you can use to assess quality. And there were a few parts to the survey. First, there was an organizational component that we asked questions about the structure of their organization, what services they provided, what kind of patients they see, what kind of protocols they have in place, how medical physicists are used, and their experience optimizing dose. We have really different kinds of organizations: academic, private practice, community-based, public. They were really a broad range. And then we also have what we called our implementation survey, which asked particular questions about how each organization approached quality improvement. And this was more about their systematic approaches to quality improvement, not just within radiology, but in their broader organization, as well as questions to assess how ready they were to make change. And we had three separate parts to this implementation survey. We used something called the Physician Practice Connection Readiness Survey. We used something called the Change Process Capability Questionnaire, parts 1 and 2, and then we created new questions that were specific to radiology. These results have been published in JACR a few years back. So the Physician Practice Connection Readiness Survey, there are questions about systems that have been shown to be associated with quality improvement. Both of these surveys were developed for assessing primary care practices and how they go about quality improvement. There is no such model for radiology, so we basically used these existing measures from other fields and then adapted them to radiology. The second part was something called the Change Process Capability Questionnaire. It's part 1 and 2. Part 1 had 23 questions about organizational factors that are believed to be important for practices to improve, and 16 questions about different strategies for improving radiology services. And then lastly, the radiology-specific questions were 9 questions about an organization's CT protocols, what their quality improvement experience and use of dose management software was like. One question asked about the organization's priority for improving radiation dose in comparison to all other priorities. And just a single quick slide on the analysis. To study the effect of each survey question individually on mean dose, we fitted a log linear mixed models where we had question of interest was the fixed effect, and the dose, which we used the DLP for each scan as the outcome. And again, one question at a time, and then put all together, so looked at what stands out among all the questions related to mean dose. And then separately, to study the effect of high dose, we used a logistic model where the outcome was whether the DLP was above 75th percentile at baseline. In our registry, that's about 1140 milligram. So we sent these surveys. I don't remember how many times we sent them, probably 3 or 4. But in the end, we had completed surveys from 90 of our 100 centers, which we were very pleased with. These surveys were completed by the organization's principal investigator, plus a leader from each of the individual center. In total, we had 5 lead radiologists, 40 non-lead radiologists, 6 lead technologists, 35 non-lead technologists, 3 administrators, and 1 respondent to a role we didn't know complete the survey. In total, I mentioned that we were going to look at the relationship between these survey answers and the dose. We had about 185,000 abdominal CT scans collected during the baseline period that we looked at the relationship to the survey questions. I should mention, which I think I forgot to mention, when I say abdomen CT, in our world, that means any abdomen and pelvis, or just abdomen exam. We put them all together in one group as abdomen, because it's very difficult to know whether something is an abdomen or abdomen pelvis based on the naming of the protocol. The scan lengths completely overlap, so we just group those together as abdomen CT. So this next slide shows a lot of the results, and I want to walk you through this table a little bit slowly. Of our questions, we found 14 different strategies and systems were significantly associated with lower doses. I was surprised by the results, that these strategies actually would be associated with dose, but they were strongly associated with dose. And so we should go through them. And just so you can understand how to read this table, we'll go through first, we track patient safety measures. And it says in parentheses, non-radiology. That question asks if an organization tracks anything to do with patient safety, be it in radiology or non-radiology. So, tracking whether physicians wash their hands, or tracking if patients with diabetes have good A1C levels, whatever they track, it's just something. Asking that question was agreed to by 36% of respondents, said, yes, we do that. And if the respondents said, yes, we do that, the average dose on their baseline CTs was 10% lower. And the p-value is 0.01. So, I mean, that's an amazing observation to me. If you look at the importance of that question, I've highlighted in yellow the high dose. That question alone is associated with a 32% lower baseline doses. So if you track anything to do with quality, your doses are 30% lower. And again, the P is highly significant. The next group of questions are under practice readiness, readiness to make change. And these questions are really quite specific to radiology. So one of the questions was, we assess the impact of CT changes made, meaning we look before and after we do something. And that was agreed to by 73. No, that's the score. I apologize. I didn't really explain the scores. The scores have to do with how many components that each question has. But 71% of respondents agreed with that. And for those that agreed to that, the doses were reduced 31% of the chance of having a high dose study. Again, highly significant. If radiology leaders support dose optimization, 27% reduction in their baseline high that proportion of exams over the 75th percentile. If we lowered dose in the previous year, if they reported that, 85% said that was 25% reduction. We review protocol processes and identify areas of improvement, and leaders of optimization are enthusiastic, both associated with lowers. The next group of questions are called change strategies, how they make those changes. I heard a lot that would align with what we're describing here, both in Matt and Pavlina's talk. So first, we set specific goals for improving radiation dose and image quality, 37% reduction in high dose scans. We organize a team to improve CT dose, 33%. We tailor decisions to site needs, meaning we don't just have one rule book for everyone, 31% lower. We pilot test process changes before widespread implementation, 30% lower. We standardize workflow to encourage dose optimization, 31% lower. And then a few miscellaneous questions. The number of protocols is associated with lower dose, the number of active QI projects, and that we have good, clear images of the abdomen, meaning overall, we do good quality control. All of these strategies were associated with having significantly lower doses. In the univariate analysis, these were the processes that were associated with the largest reduction in high dose studies. I didn't highlight the average doses. There weren't as many reductions in the average doses. The overall reduction in average doses was about 12%, far lower than the high dose, which makes sense. Many of our facilities had very good average doses that didn't come down, but no one should have high dose studies. So this was an opportunity for every site to reduce. So these are the ones that really had the largest impact. There were several factors that were not associated with dose. I'm only showing you a few here, but the few that I thought were particularly surprising were that the attitudes of radiologists, whether they said they care or didn't care about dose, didn't really matter. Again, the leaders mattered a lot, but the individual radiologist didn't matter so much. Sort of, we can move everyone along to improve quality as long as the person at the top agreed. The attitude of radiology technologists did not really impact the results. It wasn't statistically associated. Having limited resources to do this was also not associated, and organizational stress going on, other things happening, was also not associated with dose. So these things that we think might be crucial, you need resources, and I'm not saying these are not important. I'm saying in our observed locations, these factors were not the drivers of who was doing a good job or not. And then I mentioned that we did multivariate analysis. We looked at all those questions at the same time. And there were 3 strategies that stood out. If the organization tracked a patient safety measure, if the organization had radiology leaders who supported radiation dose optimization, and if the physicians reported, or actually, I'm sorry, all of the participants reported they still obtained clear images on their scans, those three factors were strongly associated with dose. And statistically speaking, if all imaging centers in this study tracked these non-radiology measures of patient safety, had radiology leaders who supported dose optimization, and had clear images, the average dose would decrease by 12%, and the probability of a high dose exam would decrease by 47%. So incredibly powerful. Now, I should say, this was not an intervention where we made these things happen, where we got an organization to track safety, or they had radiology leaders, or their images remained good. This was an observation of what organizations that did well were doing. And there's something different about maybe these organizations to begin with that's associated with them having lower doses rather than these strategies. But certainly the strong association suggests that these organizational factors are really important. So what can you do? I think what I was struck by hearing Pavlina and Matt's experiences this morning, and what we learned from our own surveys, that improvement in radiation doses from CT requires a conscientious and organized effort to improve the process and systems used to deliver these services. I mentioned that we had a champion at every site, but every site did not have lower doses. Quality improvement is described everywhere as a team-based activity, and facilities that had optimized doses in our registry worked to create systems to set goals, track process, and have ongoing evaluation. They just didn't do it once, they did it on an ongoing basis. The most important factor that drives optimized doses is having radiology leadership that is committed to support quality improvement. It's the reason I asked Matt how he got his leader engaged, because I think this is the most important factor. You need to have leadership that really cares about the topic. And I also think that if people want to get involved in this work, the best place to start is to begin quantifying your current doses. It's a starting point for assessing areas where improvement is needed, and it's the most impactful place to start because you can show the leaders that this is how you're doing, and this is where we need to do better. And without that information, it's really hard to proceed. And that information can be obtained in lots of different ways. Certainly, dose management software is incredibly helpful, but it's not absolutely required. There are lots of other ways to pull the data. The way data are currently stored, you can get the data from every CT scan. And given how many scans we do, you don't have to do data collection for anything like the amount of time we've done. You could do it for a week to get meaningful data of how you're doing if you're not doing it at the moment. Thank you so much for your attention. I will stop here. And I'm not sure if there are any open questions that people have. Please put them in the Q&A or in the chat. I'd be happy to answer questions. I'll give people one more minute, otherwise I'll go on to the next talk. So there's a question in the chat. What sort of patient measures were you inquiring about in terms of tracking patient measures? Can you expand on that? So hospitals, as well as imaging facilities, are required to track certain presentations, and they also track other measures that they believe are important. So things that they are required to track. This might be by CMS as part of their pay for performance programs. It might be for the Joint Commission as part of what they're required to do, might track a large number of things. And I believe what that question was trying to get at is how much the organization and the individuals in that organization are really motivated and involved in the day-to-day tracking of measures. And just the process where you learn how to track data, where you learn how to quantify data and you follow trends over time, I think reflects just having a quality improvement mentality, that we know we have to do better, and gives you the tools to do that. And I think an organization that has those tools, having used them for any reason, allows the radiology department to try to draw on that experience to try to measure radiology. I think radiology departments are probably a little less in the business of tracking measures compared to a medicine department. We have less academic expertise in how to do that. And I think we need to step up a little bit and do more of that. And having an organization that is used to that, I think, is a really good motivator of doing quality improvement, and therefore in our study predicted change. So I think it's a good time to move on to the next talk. And feel free to add questions from the first talk, and I will address them at the next Q&A.